Hello everyone and welcome back to another video. My name is Philip and today we're going to be talking about RTS Object Classification. So this is something I actually built inside my game and I think it's going to be very helpful if you did for your own game as well. Define the things you want and try to build them inside your engine of choice and having them being classified and stored somewhere so then later you can apply logic between objects much easier and much cleaner. This in turn is going to help you keep your code much tighter and the logic of your project much better. So there are a couple of ideas and concepts that are going to be useful for you building your project. So in the case of our RTS. So what means classification? So how does your objects know how to interact with each other? So how do they know that they're going to be talking against one another? So let's give an example here with our RTS world. So it needs to handle fog of war. So it needs to tell all the units to keep dissolving the fog of war that's going to be generating. But then begs the question, what are units? So classification is a way to turn your engine objects into game objects. So this way we can establish a logic between two game objects as we want. So in our case, we would like to handle our RTS worlds to handle all the units. So our RTS unit is just an abstract concept of a couple of engine objects, which could be a Node3D, a mesh instance, an animation player. And this script is going to use those engine nodes to become an RTS unit, which is an abstract concept. And we want this RTS units to have an artificial intelligence. We want it to have movement and attributes. So the idea with classification is for you to recognize this series of objects as a single abstract object that are going to be used for our own project. So there are two ways you can classify your objects, by structure or at runtime. So by structure, you basically assume that objects will have a given structure. So Godot will have in the future features that is going to allow in our scripting language of GDScript to have those structures to be implicit, to force us to create those structures. So things like interface, traits, stuff that we can use to make our structure. But at the moment, we don't have those. The way that you can build a structure, whenever you call objects.run and you give an object type, this object is going to have this function, otherwise it's going to run into an error. So we are going to assume that all the objects we'll be accessing will have the run function. This by itself, this concept of having a run function is a structure in itself. On the other example here, we know that for every object that is inside this group array here, which is called resources, we know this is going to be a resource object. So we can assume it is going to have a couple of attributes that's going to be similar for every single resource, so things in common. Or we can define the classification of objects at runtime. So usually you see this by in the code running if an object is something or if it has a specific variable. So I don't like to do that type of coding and I want to avoid it because at runtime, usually it's a bit slower because you're always checking if that is true or not. Whereas by structure, you already know that is true. So you don't need to keep checking. You can just basically run the code. So here we presume that our object has a run function and a type. So whenever you pass this function with this parameter, we know that's going to be running an object based on its attributes. And here the same way, because we know that we have only resources inside this group, we know that whenever we fetch objects from this group, they are going to be working as resources. So at runtime, every time you check if an object is something, this is going to be hitting performance eventually. So the same way we are checking here if we have a resource, but we don't know its type, then we can run this check here at runtime to see if it's a wood type. So this will be better organized if you simply want to run objects that you know are wood objects instead of having to check them. So there's some advantages to both methods here. So at runtime, it's much easier to implement. You basically is going to keep checking, create structures with your conditions to build some sort of classification to your objects. So the advantage of that is it doesn't need to be stored and it's very easy to implement at first. But the lack of structure isn't great because it's going to eventually run your performance a little slower. And whenever you want to expand your code, you're going to find lots of areas that they have custom code made for them and the project does not have a structure. So by having a structure, it's much easier for you to expand your code because you already know what objects are going to be running through a structure. So by structure has its own benefits because you have to do it before you execute the code. So you already know what things are going to be running at whatever places. So you don't need to keep checking or executing a bunch of conditional checks, a bunch of ifs. You already know where objects are and what they can do with it. So the way that you are going to be running in this case to be faster than runtime is for you to be storing these structures somewhere. So you have to cache these values to have to avoid redefining it later. So let's say you can do both methods at the same time. You can give a shot at runtime whenever you start the game, and you create basically a cached variable that's going to contain all the information you need for objects just a single time. So you only do whenever you need. So on the first frame of your game, you run this structure and you classify all your objects. Then later you store it inside a RTS world or some kind of data holder. Then later you don't need to keep running checks to see if objects are of a given type. You already know where they are and what they can do. So that in turn is going to make your code run much faster, and you're going to run into less trouble whenever you want to expand because you already know where everything is stored at once. So you can classify your objects in two ways. Here we are going to convert your engine objects to your RTS game objects through a classification method. So here I'm going to give you two examples. You can do either through object attributes or you can do through node hierarchy. So through object attributes is most commonly used. So you can do that at runtime or by structure. So basically, if you run into your code and say match object type, you're basically assuming that your object has types. So running a classification of objects through attributes is like this. You run a match to your object type. So you're assuming that you're going to have a type variable constant for your objects. So you can run code specifically towards those object types, instead of having to check if you have an object type variable inside your objects, which is going to run a little slower. Now, through node hierarchy is almost the same thing, but here you're going to basically be creating groups inside Godot using the nodes. So every single object in Godot you have to place somewhere. So here the idea is for you to keep placing objects inside specific objects. So the hierarchy you're going to be building is going to be creating the structure you need. So this is another way you can do it. So we know that for each object that is going to be inside our buildings group here, inside our node buildings, we know there's going to represent buildings. So we can place any buildings we want inside of that. The same is going to be with units or resources. Through the object attributes, if you do a if object type in-house object, you're going to be checking if a variable exists inside an object. So that'll be almost the same as doing a object dictionary dot has and a given value. But if you do this, every time you're going to need to run code through an object, you're going to face a lot of issues regarding performance. So instead, it's much better if you imply a structure and you only execute the object based on its attributes. So in this case here, we are implying that every object must have a var name type. Otherwise, this code is going to run into a problem. But this code is going to execute faster than this one because this one also has the problem of checking if a variable exists in an object by giving a string. So it's basically checking for characters instead of here, where we check basically with a enumeration or an integer-based calculation. So this one is much faster as well because of that. So with calculating at runtime, if your object is something, is much more modular and abstract coding. So you can place objects anywhere you want, and through a simple line of code or two, you can place a lot of conditions to make a structure with them at runtime. So you're basically converting your engine objects into game objects as runtime through a set of conditions that you're going to be placing. Whereas if you want your game to run a bit faster, you're going to need to build a structure to basically just run objects based off how they are going to be working inside the game. So based on their object type, their variables, their attributes, but you're not checking if those variables exist or not. You're simply running them from the code. So this requires you to be much more thoughtful about how you're going to be organize everything. So let's say that you create a function for all of your objects, and you want to every object to have this. So whenever you want to execute something, you just call the function, and every object is going to be processing it differently. So basically, you're going to assume that every object is going to have the code that you are running. So this by itself implies having a structure inside your project which doesn't require you to be checking if variables exist inside an object or not. So this is more towards the caution side of things. So if you are worried about your code having bugs, usually do this. But if you have been planning how your project is going to work inside out, then it's much faster for you to simply run the functions you want without having to check if an object is of a given type. So that's the idea of classifying your objects. So by converting the engine objects into game objects, you're basically building your project. So in the case of our game genre, which is an RTS, we want things like game world, fog of war system, a terrain, units, building, and resources. So all those things we want as game objects are actually abstract concepts. These are things that we want our game objects to do, to execute. So our job is to basically take all of those engine objects and tell them what we want to do. So in case of units, we want objects that can move, attack, work, repair, reel, scout. And for buildings, we want objects that can attack, research, train, store, defend, exchange, etc. So basically, you're defining the things you want your objects to do and try to build them use the Godot game objects. So in the case of your engine of choice objects. So the last step for this is how you're going to actually make them do it. So how you're going to make code for objects to attack, move, work, repair, how you're going to be defining that. So once you have defined the abstract concepts you want for your objects to be built, you want to define your game objects. So you want to classify some structure that is going to be using the engine objects to do the abstract things you want. Then the next step for you is to define how you're going to execute the actions you want to realize your abstract concepts. So in the case of units, we want to move, attack, work, repair, and how you're going to achieve that. So the next step is for you to develop a series of code that's going to provide the behaviors you want for your game objects. So in the case of units, we can use navigation server to get simple paths so we can move our units to wherever we want. And after you have built somewhat a group of coding, after you have done some steps towards coding, you're going to find that you're going to be doing almost the same thing a lot of times. And this is the time that you can detect places where there are structures being built. So with this, you know that moving, attacking, and working is almost the same thing. So you're basically moving towards somewhere and doing something. So this can be a structure code that you can implement inside your artificial intelligence to do basically the same thing, to move towards a given goal and to do something in that specific place. So this is almost the same behavior and should provide you with a structure that you're going to be building inside your artificial intelligence code. The same thing here, we want to make buildings train, research, and exchange resources. Almost all of these functions here are going to be using an interface button to connect towards them. So we are most likely going to be building an interface button system to connect a bunch of signals back to the player interface and to be reacting also towards our objects. So you can see here that you can start detecting whether you need to build structures or not to help you build your projects. So this entire idea with RTS object classification system is for you to turn your Godot game objects inside your game objects through the definition of abstract concepts. So you basically list things you want your objects to do. Then you're going to define actions for those behaviors, and later you're going to define how you're going to be doing that. And you can classify your objects so each object knows how to interact with other objects. So for units to be carrying resources towards a building, it needs to know that these objects are buildings, and this you can do in turn through the classification method, which you can apply towards a structure. So you can define before your game starts running or at the first frame and cache all that structured information back towards somewhere that objects can access it later, to avoid having to run them at runtime every time in order to have a better performance towards your game and to also have a cleaner structure towards your code. So hopefully you found this useful and it can help you with building your own projects. And that's all I have for you guys today on this video. So hopefully you found this useful, and I'll see you on the next one.